Okay, this is our May meeting. It is now 10 o'clock, so we're going to get started. Admit. All right, well, the year is winding down, so we've got a little over a month left. Our last meeting was held on April 30th, 2025. Cody Shamrock with Leonard Bus Sales presented on the updates and changes since last year to the International Electric Bus. And it was a informative meeting. It was also recorded and it's on our YouTube channel. The largest change is the body style. The let's see, they got a 10 kilowatt heater it's moving to a 20 kilowatt heater, and that 20 kilowatt heater, we're looking at doing that ourselves. We didn't want to get where the heater would start robbing our mileage, so we chose not to go with the updated heater. But as we're finding out, the new heater is more efficient and it's not supposed to affect our mileage. So we're going to try one of them, I think, and move forward. And of course, I'll let everybody know how we make out with that. They are using a lower viscosity fluid in the rear axle, and that's getting them a little bit more range, about 6% range. So that was kind of an interesting piece that they're doing. They have the 3 cooling systems. They still have that. That's been the same. One for battery, one for the cabin, and one for the electrical system. Still running the 6-phase motor. Air disc brakes. Their motor is about 342 horsepower, 1,700 foot-pounds of torque. That hasn't changed. That's been the same. They got a 5-year interval on changing their coolant. The cooling system, just like their other buses, has to be vacuum filled. Make sure that there's no air pockets in there. We want to change the compressor intake filter every year. So that's going to be something we're going to put it on our PM schedule. Once a year, we're going to change that. We have they want us to start inspecting the plugs for cracks. Those are the disconnect plugs under the front, and there's some towards the back. We want to check those for cracks and don't remove them. They said just check them. If they need to be replaced, they can replace them for us. They're seeing where the bus, because of where they're located, stuff runs over us, something in the road, and it causes damage to those plugs. Of course, the orange cables are all still the high voltage. Their governor will be incorporated into the dryer moving forward. And again, he spoke a little bit about the batteries that they're using, and they are the lithium iron phosphate batteries, where they will smolder more than combust. Either way, though, they'll still burn, from what I'm told. So evacuate the bus and let it go. But that was his meeting. Does anybody have anything with the EV buses to discuss? Anybody that owns any? I know we have our chargers. We've got them now coming on at midnight till about 5 o'clock. We can charge our buses in about 4.5 hours. That's from about 60%, 50 to 60%, up to 100%. So by having them come on at midnight, it's even less money per kilowatt hour. So we did have them coming on at 7, and now we're having them coming on at midnight. We had like our heaters. I know I already spoke about that. We are probably going to try one of the heaters or two, and we'll compare them before we do all 4 of them to make sure that we are getting the same kilowatt mileage. Today's presenter will be Roger Harrod with Matthews Bus Sales, and he's going to be presenting on the Thomas bus, electric bus, any changes and updates since last year. So go ahead, Roger.
All right, let's see if I can get my presentation screen up here. I know I got too many things open here. I have to come over here. Okay. Let's try this again. Oh, there we go. Let's see if I can get this up. This come up, Dan?
Yeah, I can see it. If we'll see if it advances when you move the slides.
How's that? Did it advance?
No.
Oh, I love the system at times. Let's try it again. I want a window. Percent. There we go.
All right, there it is.
Super, thank you. All right, for 2025, we've gotten, finally, they've been promising us changes for so long at times. And again, the manufacturing people themselves, they run behind schedule. And it looks like our new version is going to be out here shortly. And we're kind of pleased with that. This is our current version. We've actually made some upgrades on this one as we're going. As we've seen in the past, we've got our vehicle air system in the back. That's not changed. We've got our powertrain and batteries in the center. We've got our control system up front. Cutoff switches have not moved. They're in the low voltage are in the battery box. The high voltage cutoff is under the hood on the high voltage junction box. And our MSDs, the one you were talking about that possibly could crack in the IC units, our MSDs are on the back of the batteries. There's only two because I only got two batteries. And they're pretty well protected back there. That's a good place for them. Now, we have upgraded to our newer batteries, and that was actually done last year. We went from a 226 to a 244 kilowatt hour battery. We've also upgraded our air compressors. We went from an oiled, water-cooled compressor. We changed over to a no-oil, air-cooled system, which is a lot easier to service, a lot more reliable package for us. And we're really pleased with it. We've actually upgraded every old one to the new one as there's any failures in those ones. They did it, but they were prone to some problems. The other change we've made is we've added an access cover in the floor behind the doghouse. There are several large connectors down inside here that are protected by a skid plate, which makes them a little difficult to get into without removing the skid plate. So they've actually added an access cover, and that will continue on the new product as well. Now, training update. Our low voltage training for drivers and shop personnel has not changed. It's a very basic program. It's basically how do you start it, how do you stop it. Don't touch orange, which everybody is going over and over. Don't touch orange. Don't touch the MFDs. They're orange in color. And there's an HV2 program for your technicians. Your technicians, it's basically the total on this is about 4 or 5 hours for both of them if you had to go through for the mechanics. And basically in the mechanic area, they're not touching orange, but they can touch everything else. So basically it's an identification of where is an area you can get into, no problem at all, and where you're going to have to get some help with it. Now, making your own high voltage repairs. This has been talked about by everybody, and everybody's been very hesitant at this point because of the high voltage situation. This looks like it's going to be available. We aren't certain exactly when this is going to be finalized, but there are locations around the country that are already starting training on high voltage training, so you can do your own high voltage work within limits. Now, even our own technicians, if we're working on high voltage, we just don't go in and open it up. We actually contact the factory, say this is what we have, and they send us an instruction sheet. This is what you can do. And the same thing will apply here. If you had a trained technician in this, you don't have an open carte blanche, go and just work on high voltage, but you can actually get a hold of the factory, get a hold of us, and they will give you the exact instructions you are to follow, and then you don't have to wait for somebody else to come in and do it. It's a good program. Right today, though, it's factory and dealer people only work on high voltage until we get this changed. And again, that looks like it's shortly. That's going to be around the corner. All right, how do you identify the Julie? This has not changed, but I want to review it. Again, our logo, we add the blue to it versus the red that identifies high voltage. We have the Julie sticker. We've got the hood ornament changes from the black to the blue. Fourth quarter last year, they added a new EV sticker, diamond shape, similar to other alternate fuel packages here. This is on both sides and on the rear. Since that time, we get told about as much as everybody else does here at times. They've added another sticker, and they're on both bumpers and again on the sides with just a big EV. Now, these new stickers were not provided on the original buses, and our intent is to get these out to everybody that currently has the Julie product. They can get they'll have that same identification capability on their units. Low voltage maintenance. This is a situation that we've run into and out of for several times. Just like the diesel units, there is no difference. If you drop below a certain voltage, this thing's not going to start. Usually on the diesels, it's around 10.5 volts, and we'll have problems starting. The starter, the system just won't come up. Ours is around 11 volts. For the Julie package. And unfortunately, on all these newer units today, with all these computers we got on board, there are parasitic loads on these computers, on these battery packs, and it can drop below 11 volts. And that's the point at which the unit won't start. So we just went through a campaign. In fact, here's the campaign number. We added what's called a gigavac switch, which is located right here in the battery box. And it continuously sources or identifies the voltage from the batteries. And when it drops below 11 volts for 60 seconds, it breaks the connection. So there can't be any more parasitic losses. That should allow us to restart without any problem. Now, the situation is, how do you turn the voltage back on so you can actually do that? There's a battery voltage cut on or connect switch right here next to the cutoff switch. We just flip that switch. You have 60 seconds from here to get up into the cab and turn the ignition switch on to the run position, which you should see the dash come up, then over to start position, and open up the contacts onto the, or close the contacts on the high voltage system, which would again, just recharge the batteries as necessary. Or if the battery's just not going to be used, the bus isn't going to be used for 2 weeks, it's going to go dead. So we've recommended in the past, and we continue to do it. If you got a bus that's going to be sitting, turn off the voltage and just go to the battery box and turn the switch to the off position, and it should be good. In fact, even with the diesel units, we've done this for years. We've had a cutoff switch on our batteries for many, many years. And we've always encouraged you. Get a bus sitting for a long time, turn off the batteries because the parasitic load will kill it. All right, this is another sticker they're now installing on the units. There's one on the outside of the battery box door. There's one on the inside, which continues on telling you about turning off that switch. And there's a second decal assembly, or a third here actually, on the high voltage junction box, which now really identifies what our high voltage cutoff switch is, because there was nothing on here before. And again, these decals we're just out in the fourth quarter, and we're in the situation now where we're going out and having these duplicated, and we're going to get these out to all existing units, so you will have all the identification, all the warning stuff you need on it. Bendix and Telepark is standard in the Joule packages. It's an option in our diesel units. But if you haven't used this system, this is a pretty sophisticated package. It really is a benefit to the product. All Joules come with Telepark. It's an electric switch versus the old PP1 valve, but you still pull it to apply it. You push the release. The big difference is it takes all of one finger to put behind that edge right there and just pop it out. IC's using this as well. It's an electric switch, so you have to have the ignition on to turn on the park brake system. You need the ignition on to turn it off. And when you turn it off, you also have to have your foot on the brake pedal, so it is a park brake interlock system as well. The need to fan down the brakes on these newer vehicles is really passé. We really don't need to do that anymore. If you pull the keys out of the dash on these newer units, you cannot take the parking brake off. It's on, it's locked in. And it really does save a lot on the slack adjusters and everything else on the bus. And if you think about this, I'm not using a lot more energy with the air compressor to recharge the whole system every time I start it. So it's a savings for your batteries as well. When these LEDs are lit, the park brake is on. When the LEDs are off, they're not on. Very, very simple system. We're going to talk more about the lights in a minute. The system can be applied for manually for emergency braking, and that's part of the DOT requirements, but we'll talk a little bit more about that in a minute as well. Now, this is the part that you have to be aware of. Telepark is designed to prevent unintentional rollaway, where the driver, for whatever reason, the park brake is not set and the driver is not paying attention, or he has left the vehicle and this vehicle starts rolling across the parking lot. This system is designed to prevent that. And the way we do it with the Thomas bus is, if that bus sits idle for 30 seconds and you've got little or no speed on it, it's just sitting there. There's no throttle input and there's no service brake applied. And Telepark applies all by itself. And in the case of the electric vehicles, it also shifts the transmission to neutral. Now, the mechanical ones used with the diesels do not have this last little bit. This is added for the electric vehicles because of the noise situation. If the parking rules was to apply on a diesel units, you could still hear the engine running. You'd know the engine is up. This system doesn't turn the ignition switch off, so the batteries on a high voltage system are still connected to the transmission or to the motor itself. It's still going to work. We shift the transmission to neutral immediately upon this happening. Now, when it's auto applied, the lights here flash. Boom, 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 boom. They flash, telling the driver what? You didn't set the brakes, I did. And in that case, you can't just turn them off. You have to acknowledge this. And you do that by applying the brakes. You just put one finger behind the switch, you pop it out. Now the lights are on steady. Now you can put your foot on the brake pedal and you can turn it off. But it's a great system. This works really good. Also keep in mind, Telepark is tied into the charging system. If you've got a charger plugged in, just the plug in, that's all, not charging, just the plug in, it will not let you take the parking brake off. We do not, none of us want you to drive away with that cable still attached. That is an extremely expensive failure. You don't want to do that. Okay. Emergency braking. Two phases to this. Above 12 miles an hour, if you pull a parking brake switch for 3 seconds, it will spring brake, modulate, apply. The service brakes will slow the vehicle and it will shift the transmission to neutral. Releasing the switch releases this braking system, but it doesn't shift you back into range. Now, for the life of me, I can't see where this is ever going to be used in a school bus. It's an option of IntelliPark. And maybe something in the truck industry they really think is the greatest thing since sliced bread, but I have never seen this really come to phase in a school bus. Now, under 12 miles an hour, we have a DOT requirement. We have to have the ability to stop the vehicle. And if you hold the park brake switch out for 3 seconds, it will set the park brake. It will also shift the transmission into neutral, and it will stop the bus. Now, the one area of concern here is the switch must be held for 3 seconds for these operations to work. Now, when you're stopped, if you pop that switch, it's on. But when you're moving down a road, we don't want an unintentional apply. You have to request that the brakes go on. And that's done by requiring at least 3 seconds on that switch. And we have had concern with some DOT inspectors where they say, well, we pulled the switch and it doesn't work, it fails. No, it's not supposed to work like that. It's supposed to work as an intentional apply of the park brake, which means you have to hold that switch for 3 seconds. If you do that at 10 miles an hour by 8 miles an hour, you're stopped dead. This is a very quick system, but it does take 3 seconds for it to work. All right. This is a chart. Let me back up here. Number 9. This is a chart I put together on the lights. Now, all of us know that what's gone? Well, the wigwags are gone. I never liked the wigwags, but I like them. There's an advantage to having a wigwag. And the advantage with a wigwag is when that damn thing's hanging straight down in the middle of the windshield, the driver sees it and says, I can't go yet because I haven't got enough air pressure. Well, IntelliPark gives us back a wigwag. How's this thing work? Now, first off, we've seen the lights come on when you turn it on, the lights go off when it goes off. I'm looking at the upper lamp only. If the upper lamp is lit, the park brake is applied. I don't care what the lower one's doing. If the upper lamp is lit, the park brake is on. If the upper lamp is not lit, the park brake is not on. Now, if both lamps are on or both lamps are off, that's the normal condition we want to see all the time. We want to see both lamps on or both lamps off. That's the normal way. However, if the lower lamp is blinking, we're trying to get the driver's attention. Because when the lower lamp is blinking, I don't care what the upper one is. If the lower lamp is blinking, it says I'm low on air pressure. That's my wigwag again. It's back. Now, actually, there's 2 different pressures here. If the park brake is set, it's below 60 PSI. If the park brake isn't set, it's below 90 PSI. But it does tell you I'm low on pressure. Now, there's an exception for this. This is something there to attract the driver's attention. We're low on air. It could also mean something else. Most of the new dashes have a man read section, something like this on the bottom. And this one says, IntelliPark service soon, verify park before exiting. This is telling you what? That flashing in this case is I have a fault in the system I should be maintaining. I should be looking at. Likewise, if both lamps are blinking, both top and bottom, that's that auto apply thing where the driver didn't set the park brakes, the system did. In this system, again, we're telling them, we're flashing those lights, telling them, you didn't set the park brake, I did. It's an eye catcher. But again, it could be an eye catcher for a fault code too. So if your dash is giving you something like this, it's telling you, I've got a fault in the system. I'm going to have to manually fan the brakes down to set the park brakes, the spring brakes in this case, and get a hold of somebody because there's something wrong with it. This is a great system, and it does add back something that we were missing. And I've seen fleets having problems with this, especially on demos. They go out there and they think they've got enough air pressure. The first time they hit the brakes, of course, what happens? Park brakes apply. And that's not a good thing. So this is really a great system. Brake status is the top light. If it's on, it's on. If it's off, it's off. The bottom is typically air pressure. And that's your wig wag back again. And that's a really neat feature. All right, DOT brake test. This has not changed. This is a standard test that DOT comes in. We have to bring the air tanks up to 100 PSI. Okay. And with a diesel, we'd run the engine with a high voltage unit. We'd put that over to start and engage the high voltage system. We'd let the system come up to air pressure. And then we do what? We turn the ignition switch off and turn it back on to run. So we're just on ignition. The compressor no longer is going to work. Now we're going to check your brake throws. We're going to drop the wet tank the gauges should hold. We're drop the auxiliary tank if you've got one. Should drop the 50-pound primary tank should hold. Should have a low air light buzzer. Secondary tank. Nothing has changed here. Okay. Then you're going to have to do what? Start the engine again, or high voltage in this case. Bring the compressor online. Get the system charged up to 100 PSI. Turn it off. Turn it back on to run. So you've got your ignition on. You do your final test. You're on drum brakes with your measuring your throws and with your primary tank and such. The problem is I got IntelliPark in here. And IntelliPark is going to do what? If you don't hit the brake pedal, now you do hit a lot of brake in this, but if you don't hit the brake pedal every 30 seconds or you don't hit the throttle at all, this thing's going to apply the park brake right in the middle of your DOT test. Simple fix. The operator up inside the cab puts his right foot on the throttle and pushes down on it, and just hold the throttle down somewhat. As long as the throttle is being used, IntelliPark will not come on. And that's the simplest way you can work with this system. It's a very, very simple package. Other things with IntelliPark we're not going to cover today. All right, we were talking a little bit about this earlier, folks. Heating the bus versus lost mileage. Last month, we talked a little bit more about it. This is the expansion tank in our bus for the bus cab heating system. If it's 70 degrees outside, that tank ought to be cold because the heater shouldn't be on. And I'll tell you quite honestly, in our own experience with demos, just showing driving a bus to a scene, if the driver don't know, what happens is we get to the scene where we're demonstrating the bus, and that tank's 180 degrees, which means what? For the length of the time he drove that bus from our location to that demo, that heater has been on using what? 20 kilowatts of energy. Now, the interior safety uses the batteries, obviously, to heat the water. That's why in the wintertime, we lose some mileage because we've got to heat water to keep the inside of the cab usable. At full heat, now this is the amazing part. If you got that thing cranked all the way up to 20 kilowatts, you could lose, for every hour this thing is on, you could lose 15 miles of range. This is a tremendous amount of loss. Now, that is controlled by that switch right there on a Thomas bus, this one right here. Those fan switches, which the driver has been using for the last 25, 30 years to control the temperature inside the bus, don't do a damn thing with an electric bus. Turning those fans off doesn't save you a bit of energy. You save energy by controlling where this switch is. Okay? The temperature is also variable. The further you turn it, the more energy it will consume. So the point is that once you get heat in the bus, what do you want to do? You want to turn this switch back. In fact, if you can, you want to turn it off. Now, this is the switch arrangement we've had since day one. We have recently changed the switch backing plate. And that backing plate now says heater and pump active, because the drivers, we had to do something to show them how to save range in the bus. And turn the heat off if you can. Turn it off, but don't leave that switch. I mean, this is so common. You see that switch is cranked all the way over to here, and it's 65 degrees out. You're just wasting energy, Okay. This is Gen 2. This is our big change for Gen 2. We're going to the Accelera 14 XE powertrain axle. This is what? This is a motor and a transmission built onto an axle assembly. Now, this one is equipped with air disc brakes. Can you get it with drum brakes? I hope not, because drum brakes cost me energy. It takes almost twice as much air to operate a drum brake as it does to operate an air disc brake. And what creates the air? The air compressor using the batteries. So I would recommend only, I know IC said they're only going to sell it with air disc brakes. I don't know what Thomas is doing yet, but I would not order drum brakes on them. Now, why do we use a transmission? We've used a transmission since day one. We don't have as big a motor. Ours is only 295 horse. You don't need 350 horsepower to drive a school bus down the road. You need 165. That's all a Cummins engine produces at 65 miles an hour. It's 165 horse. You need torque. And you can get torque two ways. I can either put a big damn motor on here with lots of torque, or I can put a smaller motor in and put a 2-speed box with it. And the 2-speed box, what's a transmission? A transmission is a torque multiplier. And that's all we've done. It has worked fine for us, and we're going to continue to do. And when you get into bigger vehicles, they all do this. They all run transmissions. In fact, actually, we run wheel planetaries in some of the big tractors to give us what? Torque multiplication. All right, this is a 650 volt AC 3-phase motor. We're going to be operating at 800 volts on the new units. Currently, we're at 400 volts. We run 2 batteries in parallel, giving us 400 volts total. We are going to be changing this to the same 2 batteries, or we're going to run them in series, which will give us an 800 volt system. Now, this 800 volts does some nice things for us, by the way. But our layout's going to be the same. We've got the vehicle air system in the back. We've got the control system up front. We've got the batteries and powertrain in the middle. But the big change here is I've got this big empty space that I didn't have before. And that big empty space was because of that motor and transmission and drive shafts and all that. And that created a problem for us. The problem was our wheelbase on our other buses, our Gen 1s is 259 inches, which is a long wheelbase unit. It does some things to our weight distribution front to rear axle, which we don't like. It does some steering, creates some steering situations for us. We don't have the same turning radius we would like to have with it. With the new system, we're going to a 219 and others to follow as necessary, but we're going to shorten that wheelbase up. It's going to be a big benefit for us. Expected range should raise from 130 up to 150. Well, we already got the new batteries. The new buses do have a larger range than the earlier ones did. Battery voltage, 400, 800. We're using the same batteries. We're just wiring them differently. Starting gradability on the old unit was 19%. It's now up to 28%. Gradability, we could maintain a 6% grade at 20 miles an hour with the older units. This has created some problems for us. That's going to be raised as high as 30 miles an hour. Acceleration, for those of you who care, we can do 0 to 60 in 49 seconds. We can do it in 45 now. Max road speed was set at 65 miles an hour, and it was somewhat difficult with Gen 1 to change that. There was some procedures and stuff we did that would make that different. The newer units from the factory, you can set them anywhere from 45 to 75 in 5-mile-an-hour increments, which means I could get 45, 50, 55, 60, any of those 5 numbers. You could set that up as your max road speed. Um, 12-volt batteries. We have a high to low voltage inverter in here built in the bus, which acts as the alternator for the 12-volt batteries. That was set up for a maximum charge rate of 400 amps or 200 amps, excuse me, which was fine. Until you probably look at a Braun lift somebody's going to add in the future, that may not be enough amperage. The new system can charge up to 400 amps. So we're going to take care of that problem pretty quick. We do have a new dash coming in. Looking forward to that. That's a nice looking package. And we are still vehicle to grid compatible for those fleets that want to run with that stuff. Now, there are some other things that they're talking about changing. And I'm going to just give you some highlights. These may or may not happen. This is the high voltage junction box. If you're working on the high voltage, you have to remove the cover on this box. That's the coolant tank for the body loop, the one that heats the inside of the bus. We have to physically remove this and all the brackets to get into this cover. It is a pain. And they're talking about relocating this tank over to the driver's side of the compartment, and that'll open this whole area up, and we're crossing our fingers on this one. We want that to happen. The other change is the power steering motor. This, by the way, is a 4-horse electric water-cooled motor. Power steering takes a lot of load. It's a heavy consumer of energy. And this works fine. It, however, creates some maintenance situations for us that about 3 years down the road, we're not looking to look forward to. They are talking about going to a newer pump assembly here, and we're very hopeful that will go through as well. But neither of these have been confirmed at this point in time. Any questions?
Yeah, Roger, when you spoke about the park brake switch, so if a driver is in traffic, so long as he has his foot either on the brake or on the throttle, the parking brake is not going to come on, right?
You're absolutely correct.
Okay, so he can sit there for, if he's in a traffic jam, for
forever.
Minutes. Yeah,
forever.
Okay. So long as he's got his foot on the brake. He takes his foot off the brake, and it's going to apply the parking brake.
After 30 seconds.
After 30 seconds. Okay.
Which is, by the way, I've done this on driver demos, and it's really an impressive show. You sit there and you pull them out of the barn, and we're just sitting in the parking lot, and they say, okay, take the park brake off. And they look at you strangely and take the park brake off. All right. And we're sitting there, and usually most parking lots got a little grade in them. And this vehicle, all of a sudden, maybe 10, 15 seconds in, start rolling. And you see their right foot coming over to the brake pedal. I said, don't touch it. Don't touch it. And they look at you with this crazy look, and 30 seconds, bam, brake goes on. Wow, this is impressive. But it takes, it seems like a short time, but it's actually an eternity before that comes on. And a lot of people have been concerned about this coming on in traffic or whatever. It's not going to do that. The system's pretty well geared up. It works correctly.
Just a note on that, Roger, what we have noticed with some of our drivers, a learning curve with that is they can't toe tap the brake pedal, because with the regenerative brake, they'll sit in traffic and the bus will creep along. They'll barely rest their toe on the brake.
Yeah.
And all of a sudden it kicks on. Then they go to panic mode during traffic. They try pushing the brake off. Well, no, you have to stop. You have to pull the brake on, take your foot off the brake, put your foot back on the brake, and then release the brake. If you just push the brake pedal down and start pushing the switch down to shut it, it doesn't. You have to go through your sequence there. They get panic mode, so you have to tell them.
Thank you, John.
Don't toe tap.
Good information.
Yeah, that was a learning curve.
All right. Any other questions for Roger? Not seeing any. If you do come up with any questions, please let us know so we can put it out to the group so everybody can get the information. Roger, I want to thank you for your presentation. Again, very informative. You know, as we're moving forward with these new EV buses, everything is changing and it's changing fast. So each year, you know, we try to have at least one presentation on the updates and changes on the three main manufacturers. So thank you very much. Our next meeting will be held on June 18th, 2025. This is going to be our DOT roundtable. So we need questions. So like we just talked about today with the parking brake, that was very informative on how to do a DOT brake check. Because we're all going to be into that. And I'm assuming the other two manufacturers are going to be similar. So questions, I need everybody's questions because they want the questions in advance, and we'll make sure that it's in there. That meeting will also be recorded and we'll be able to view that as well. The floor of the On Center is filling up. We've got a few new vendors this year, which is exciting. We have it's still July 16th is going to be the setup. July 17th is going to be the show. Everybody should have a sign-up sheet for the vendors, or for not for the vendors, for the attendees. So all the mechanics, everybody should be signed up and, you know, take advantage of the training.
Dan, if I could add just one thing, at the show, we should have our new Class A electric bus on the floor.
Nice. So we'll be able to check that out.
Yeah, we're just getting into that one. That's a different animal completely.
Yeah, that'll be interesting. Well, like I said, it's you know, as we're moving forward here, things are moving quickly. So I appreciate everybody putting the presentations together and keeping us all informed on the EVs. The last thing I have is if anybody is interested in helping out with the Head Mechanics Association, please let me know. We could use some help. And other than that, does anybody have anything else to add to today's meeting? All right, not seeing any. I'm going to go ahead and close the meeting. If anybody does need a sign-up sheet for the Head Mechanics Association for the summer seminar, please let me know and I'll make sure that you get one. That being said, I'm going to go ahead and close the meeting. Thank you again, Roger.
You're welcome.